I am Benjamin Larson from the Robert Langer Laboratory in the Lisa Freed Group at the Koch Institute. Cartilage is like brain tissue, which is one of the reasons why I work on it. It's so fascinating in that it doesn't heal itself. It lacks the capacity for natural repair. What we're hoping to do is provide cartilage and bone with a natural type of interface that we've been able to grow in the lab to then implant in patients and replace their worn cartilage in the joints. So in an affected joint with a defect in the cartilage, one of the reasons it's so difficult to treat is that any cartilage or therapy added to the site will simply not integrate and will float away. And so you can't just replace the damaged cartilage with a new cartilage plate. It doesn't work. It'll fail. In the clinic, what they'll do is take that joint with the damaged cartilage and cut off the joint at the bone and replace it with a titanium post. This is not ideal for a number of reasons. The titanium post can become loose over time. The titanium joint itself can wear and produce toxic byproducts. So what we hope to do is take that same technology wherein we remove the affected joint, the affected cartilage, and replace it with engineered bone and cartilage that we grow in the laboratory. This bone will integrate very nicely with the native bone in vivo, similar to a broken bone. A broken bone will heal itself, no problem. This image is of a very thin section that we took of our cartilage and bone construct. And so the red here is really cartilage and the green is just a background stain. And luckily here we saw lots of red, meaning we were successful in engineering lots of cartilage, especially in this portion of the scaffold. But interestingly, the cells are also producing morphologies called lacuna. Those are the circles with small green dots in them. And this is similar to what you'd see in native cartilage. So in the lab, we have our 3D woven polycaprolactone. And it's woven in a number of directions. This is a cross section, and it just looks like sweater fabric or a t-shirt fabric. We take the sweater fabric, the t-shirt fabric, whatever you want to call it, and impregnate the construct with our stem cells, our adult stem cells here. And then providing the right chemical cues, we have cartilage growth medium on the top and bone growth medium on the bottom. We can see over time cartilage starts to form on the top and bone starts to form on the bottom. And in the middle, we get this really nice transition zone between the cartilage and bone, which is really similar to what you'd see in a normal tissue, in a normal knee or a normal hip, where you have your cartilage, your bone, and this great transition zone that keeps it all together.